Alright guys, so this is our third Flip the Classroom lesson of Chapter 3, and this lesson is going to be on properties of logarithms. Before we get into properties of logarithms, I want to talk a little bit about logarithms in general so that we can sort of make sense of what we're going to see with our properties of logarithms. So right here, let's say we've got log base 2 of 8. Well, right here, what is log base 2 of 8? Log base 2 of 8 is going to be the exponent we need to raise 2 to in order to get 8, so that would be 3. So right here we can say that log base 2 of 8 is actually the exponent of 3. And in general, we can say that all logarithms really are exponents. So right here, let's say we've got the addition of two logs of the same base. Let's say we've got log base 2 of 8 plus log base 2 of, let's say, 4. Well, right here, this addition of logarithms is really an addition of exponents, right? And we know that when we add exponents, we're actually multiplying the bases. Well, right here, these two logs are both base 2, but really that's just sort of telling us what we want to be thinking about in terms of an exponent for the expression that's inside the logarithm. And it's really the expression that's inside the logarithm that is the base raised to the power. So right here, log base 2 of 8, we could also think of as log base 2 of 2 to the third power. And then right here, plus log base 2 of 4, we could really think of as log base 2 of 2 squared, right? Now we can sort of see that this addition of exponents right here will translate to a multiplication of the two bases raised to the powers inside the logarithms if we condense into one logarithm. So right here, log base 2 of 2 to the third plus log base 2 of 2 squared is equivalent to log base 2 of 2 to the third times 2 squared, right? This would give us log base 2 of 2 to the fifth power. And right here, what do I have to raise 2 to in order to get 2 to the fifth power? That would be 5. And if we evaluated this as an addition, we would say that log base 2 of 2 to the third would be the exponent we would need to raise 2 to in order to get 2 to the third, which would be 3. So that's the evaluation of this logarithm. And then right here, log base 2 of 2 squared would be plus 2. And that's the evaluation of this logarithm, which equals 5, which we just got right here. So basically, an addition of logarithms we can think as a multiplication of the bases that are happening inside the logarithm if we condense that into one logarithm, right? Now let's talk about what it means to subtract two logarithms. So let's say we've got log base 2 of 8 minus log base 2 of 4, right? Well, right here, this is a negative logarithm, right? A negative logarithm, a logarithm is an exponent, so a negative logarithm, or a subtraction of a logarithm, is going to be in a negative exponent, and a negative exponent actually is a division, right? So right here, if we think about this as log base 2 of 2 to the third power minus log base 2 of 2 squared, right? Now we can see that when we condense this into one logarithm, right, this negative logarithm, right, is going to be a multiplication of a negative exponent or a division inside our logarithm. So right here we would have the positive logarithm of log base 2 of 2 to the third, right, in the numerator, because that's a positive exponent. And now right here in the denominator, this negative logarithm is going to be a 2 squared in the denominator, right? So right here, we could say that this would be a division inside the logarithms, which would result in us canceling out 3 of the 2 2's that we're multiplying in the numerator with the 2 2's that we're multiplying in the denominator. So this would be log base 2 of 2. What do I have to raise 2 to in order to get 2? That would be the exponent of 1. And if we were to evaluate the subtraction of logarithms, right here, what do we have to raise 2 to when I get 2 to the third? That would be the third power. It's the evaluation of this logarithm. Now minus, right here, what do we have to raise 2 to in order to get 2 squared? That would be 2, and that would be 1, the exponent of 1, right? So right here, again, subtraction of logarithms means that that negative logarithm, I'm going to sort of draw it this way, is going to be a multiplication in the denominator if we chose to condense to one logarithm. So that's what we want to think there. Now, finally, right here, if we're looking at raising an expression inside a logarithm, an exponential expression inside a logarithm to a power, right? That's the multiplication of exponents. So right here we would have, let's say, log base 2 of 2 to the third power squared, right? We know that inside this logarithm, if I raise an exponential expression to an exponent, that's going to be a multiplication of exponents. So this would be log base 2 of 2 to the 3 times 2, which would be 2 to the 6th, right? Which we could then evaluate as basically the exponent that I need to raise 2 to in order to get the 6th power, which would be 6, right? Right here, what we can recognize, though, is if we have an exponent inside a logarithm, right, we could also represent that multiplication out in front of the logarithm, since the logarithm itself is an exponent, right? If I represent this as 2 times log base 2 of 2 to the third power, really this log base 2 of 2 to the third power is the exponent 3, right? So right here, what I can see is I can take that exponent inside my logarithm and represent it as a multiplication out front, and then when I evaluate my log base 2 of 2 to the third power, that's going to be 2 times 3, or the exponent of 6. So this can be a little confusing when we sort of think about all of these properties and sort of how logarithms are really exponents, but hopefully we've sorted some of this stuff out and it makes a little bit of sense to us. What we want to do, though, is to use these properties to simplify logarithmic expressions. And that's what we're going to do today. So right here, looking on to our lesson, we're going to sort of talk about simplifying some logarithms, right, of the same base, right, by condensing those expressions and expanding those expressions to suit our needs, right? So let's just get some practice first. Right here, the product rule is that thing we first talk about right here. Again, right here when I'm adding two logarithms, if I've got a positive logarithm, I can see that as a multiplication of bases, right, in the numerator. So right here, I can basically say log base b of r times s could expand out into log base b of r plus log base b of s, right, where these two logarithms represent the exponents, right, and a multiplication of bases is an addition of exponents. So right here, let's say I've got log base 2 of 3x. I could expand that out into log base 2 of 3, and then right here plus the exponent log base 2 of x. If I have the addition of two logs that have the same base, I can condense them into one logarithm, right? This is the exponent that I need to raise 5 to in order to get 4, and this is the exponent that I need to raise 5 to in order to get y, right? And so right here, I can say that that would be equivalent to a multiplication of the bases 4 and y inside my logarithm. So right here, log base 5 of 4 plus log base 5 of y would be, whoops, log base 5 of 4y, right? So right here, the quotient rule is basically saying that anytime we have a division inside one logarithm, right, that thing that's in the denominator is going to expand out into a negative log, right? So one way we can think about this as is things multiplied in the numerator expand out into positive logarithms, and things multiplied in the denominator are going to be negative logarithms. So right here, r is in the numerator, so it's going to be a positive logarithm, and s is in the denominator, so it's going to be a negative exponent, and that means it's going to be a negative logarithm or a subtraction. Right here, if I've got log base 4 of x divided by 5, I can expand that out into log base 4 of x, and then right here, minus, let's erase that, and then right here minus log base 4 of 5. If I'm looking at the subtraction of two logs that have the same base, right, I can basically condense that into one logarithm, and the thing that's in the negative logarithm is going to be multiplied in the denominator. The thing that's multiplied in the positive logarithm is going to be multiplied in the numerator. The thing that's in the positive logarithm will be multiplied in the numerator. So right here, this could be log base 3 of 4, since that's in the positive logarithm, that'll go in the numerator, over 2z. All right? Now right here, we've got that power rule that we talked about. Again, right here, a logarithm is an exponent, right? So if I have log base b of r to the c power, I can take that c that I'm raising r to inside the logarithm and represent it as a multiplication of c out front, which is what I'm seeing right here. So right here, if I've got log base 2 of 9, I could represent 9 as 3 squared, right? And then that exponent inside my log base 2, right, of 2 can be taken out front and made multiplication such that I have 2 log base 2 of 3. Anytime I'm seeing a multiplication of a constant outside my logarithm, I can always bring that inside if I want to condense it and make it an exponent. So right here, if I've got 2 times log base 3 of 2x, I could call that log base 3 of 2x squared, right? So that would be log base 3 of 4x squared when I distribute that exponent. Okay, guys, so just some properties of logarithms. We are going to go ahead and try some of these out on the next page. All right, guys, so first we're going to talk about expanding out some logarithmic expressions just to get some practice with these properties. One thing we want to think before we start expanding anything out is we want to make sure the expression in the logarithm is simplified with, let's say, as a multiplication of bases, bases raised to powers. So what we want to see is basically a multiplication of bases raised to powers inside our logarithm. Now some of these already have that, and we're going to be able to expand them out right away. Others of these we're going to have to manipulate a little bit before we think about expanding them out, right? So right here in general, our first step is going to be to expand into positive and negative logarithms. So right here actually let's call this our first step, right? Our second step, we can say, is going to be to expand into addition and subtraction. And then our final step is going to be to make, make powers multiplication. So right here, if I'm looking at this guy, there are no powers. I can basically say, or everything is raised to a power of 1, we could say, right? So immediately we're already at this step, right? Everything is represented as a multiplication of bases to powers, right? Every power is 1. And so I can just expand this out into addition and subtraction. Right here, one thing I can think is that I've got 2 multiples in the numerator, so those are going to expand out into positive logs, and I've got 2 multiples in the denominator, so those are going to expand out to negative logs. So when I expand this guy out, he's going to be the common log of 2 plus the common log of x and then minus the common log of y, and then right here minus the common log of z. So this guy got a little bit big on us. Maybe we can scrunch him down. That's our expression right there. One way we can also think about this is right here, if I were to take this y and this z into the numerator of my common log, I could represent this expression as 2x to the 1, and this really would be 2 to the 1. This would be y to the negative 1, and then z to the negative 1, right? And then if I expanded all these guys out into positive logarithms, I could then take that exponent of negative 1 and throw it out front with the power rule to make those negative logarithms. So another way we can sort of see these properties of logarithms all working out here if we choose to use them in a different order. Okay, so right here in this next expression, I've got three things that are being multiplied in the numerator, right? 4a and b right here. I don't have to simplify this. This is all multiplication of bases raised to powers. So right here I can say that this is going to be, I'm going to try to give myself some narrow room here, log base 3 of 4, and then right here plus log base 3 of a, and I do not have anywhere near enough room, so right here let's make these rules smaller. All right. And right here I'm going to group this stuff, and then I'm going to take it and shrink it down. There is some smartboard magic. So right here, so draw a line there, and then plus right here my log base 3 of b to the third power, right? Now right here I could represent that 4 as 2 squared. So right here in my next step I might say log base 3 of 2 squared, right here, plus log base 3 of a, and then plus log base 3 of b. Oh god, still not enough room. B to the third, and then my last step here is going to be to throw that multiplication, or that exponent inside, out in front and make it multiplication. So finally right here, I'm going to have 2 log base 3 of 2 plus log base 3 of a, and then right here plus 3 log base 3 of, forget this. Oh, that stinks. Right when I say I've got smartboard magic. B, right? And right here I'm going to see if I can do some more with this stuff. Maybe I'll take it down here. Group it again. It was grouped before. I don't know why we had that problem. Oh, the B's in there. Okay, guys, so what I want you to do is to give this a shot on your own with the rest of these guys, and we will come back and try the rest of these in a second. So go ahead and give it a pause. That last one should be in sight. All right, guys, so I'm unpausing it after this first one because I'm realizing we didn't really talk about simplifying expressions inside a logarithm. Here we've got the natural log of 3 times the square root of 2x cubed. So right here, one thing we can do if we're looking to make this a multiplication of bases raised to a power, right, is represent this square root as a power of 1/2 and then distribute it to the 2 and the x, making this 3 times 2 to the 1/2 power times x to the 3/2 power. Now we're multiplying 3 things inside our natural log, so that's all being multiplied in the numerator. That's going to expand out to 3 positive logarithms, right? And then we can take those exponents that are inside the logarithm. So right here we've got the exponent of 1/2 and 3/2 and throw that out front and make it multiplication there, right? So that right there is the expansion of C, right? Basically sort of representing everything as a multiplication of bases raised to powers, then expanding out all of my multiples inside the logarithm into their own separate logarithms, and then throwing those exponents out in front to make the multiplication. All right, so I'm going to pause the rest of this, and we'll look at right here. We'll unpause it and look at expanding with polynomials in a second. All right, guys, so let's look at the rest of these. Here we've got the common log of 3 times x squared times y cubed. So right here we're looking at 3 things being multiplied in the numerator inside our natural log, right? So right here that's going to expand out into 3 positive logs, right? And then we can take those exponents of 2 and 3 and throw them out front to make the multiplication. Okay, so in our next one, right here, what we're seeing is 2 things being multiplied in the numerator and 2 things being multiplied in the denominator. So the 2 things being multiplied in the numerator are going to expand out into positive logarithms, right? That's that 125 and a squared. They're going to be in positive common logs. And right here, the 2 things being multiplied in the denominator are going to expand out into negative common logs, right? Now right here, this 125 we can represent as 5 to the 3rd power, and then in our next step, what we're doing is taking those exponents inside the logarithms, right, that exponent of 3, 2, and 3, and throwing them out front and making the multiplication. Our final expansion right here, log base 2 of 27 over the square root of x to the 5th, is going to take some simplifying first. Right here, I went ahead and made that 27 3 to the 3rd power inside the logarithm first, right? Instead of expanding it out like we did with the 125 and then making it a base to a power. And then right here with the square root of x to the 5th, I made that x to the 5 halves in the denominator. Now right here, that x to the 5 halves in the denominator is going to expand into a negative logarithm. And right here, since that 3 to the 3rd is in the numerator, it's going to be a positive logarithm, and then we can take those exponents and represent them as multiplications out front. So right here, expanding with polynomials. So right here, we have some polynomials inside our logarithms, and what we want to do here is basically polynomials, and we should say rational expressions. And what we want to do here is factor these guys as much as we can, right? And then expand them into logarithms. So I'll give you guys an idea of what I'm talking about with this first one. Right here, log base 2 of x squared plus 3x. I can write that as log base 2 of, right here, x times x plus 3. Now right here what I'm seeing is a multiplication of 2 things in the numerator of my log base 2. It's a log base 2. And right here what we can do is expand this out into log base 2 of x and then plus log base 2 of x plus 3. Right? So that would be the expansion of this guy. So why don't you guys go ahead and try these 2 guys, and then we will come back and take a look. All right, guys. So looking at these next 2, we've got the natural log of x squared plus 4x minus 12. I can represent that as x plus 6 times x minus 2, and then expand that out into 2 positive natural logs, right? Since right here I've got a multiplication of these 2 linear factors in the numerator. Now, I think that sometimes people get tempted to say, well, there's an addition inside the logarithm. That means I can expand that out into an addition outside the logarithm. Really what we have to remember is we're talking about a multiplication inside a logarithm expanding out into the addition of 2 logs of the same base. And so that's what we really want to be careful of here. In this next expression, we've got x squared over x plus, or x minus 2 rather. A couple ways we could think about dealing with this x squared. We could call that x times x, but what I chose to do was to say that I've got one thing that's basically being squared in the numerator, and then I've got an expression in the denominator. So when I expand this out, that thing that's being squared in the numerator is going to be in a positive common log, and that thing that's in the denominator is going to be in a negative common log, and then I can take that exponent of 2 inside of my positive common log and make it a multiplication of 2 out front, right? So that's how I would choose to expand this guy. All right, so I'm going to end this video. Ran a little long. We're going to break this up into maybe 2 videos or 3 videos. We'll see how it goes, but I'm going to stop this guy, and then we will move on to the next.